All right, good morning, everyone. Let's get started. So we had a bit of technical issue with in the classroom computer. Apparently, the old desktop stopped working anymore. They replaced with a laptop. So that's why it took me like a extra five, well, almost 10 minutes to set up the new laptop. Um, and going on, I don't know, is it because they're gonna be in about 2 weeks, there will be intensive like whiteboard teaching. So I don't know is because now I cannot turn on the camera, so but I can share my slides. That's is a bit, let's see. So hopefully they can fix it next week. Then we don't have an issue um with the teaching. Okay, so today we're gonna continue with MTI. Now the only thing now is I need to, okay, so now the issue is I need to set up okay, I guess I have to wait for me for another second because now I have to um, log into the Seowolf mobile extern, log into the Seowolf so I can show you some demo. Let me just download some, okay, photo version. And just download the mobile extern and the sign in so you guys can, I can show you guys a demo. I had everything set up for the lab for the class computer, but this is a new laptop, so I have to redo everything again. Okay, should be just another like another minute. Okay. SSH login.co stream video. Okay. Don't see password. So say password. Um, huh. Okay. Sometimes it's I don't know what happened. Take a couple tries. Okay, so as I mentioned last time, this is under the class directory. There's a folder called example 2025. This is a folder where the all the examples has been stored here, so you can like try them out. The only thing when you try them out, for example, like just open the one of the Slurm file. In this Slurm file, it is point to I'm running the program under my home directory. So you have to change this is to your, you can copy the program to your own home directory, okay, and it may change the path. So then you can run your own. This is once you have in that, then you should be able to repeat these examples. Now, okay, with this setup, I don't think I need any Jupyter Notebook. So then let's go back to the slides. Okay, we will go back. We'll come back to the example in just a second. Okay. Let's finish the slides for. Then we can go to the examples. So we talk about what is MPI, which is basically is just a collection of functions and macros, or you can see it's a library that use the programs writing in the like the C, C++, Fortran, the Python. Then people can use that to realize the communication between the computer nodes in the actual HPC environment. So it's not a new language. It's just a collection function. But it's a language independent. So if you are interested in learning more about this is the Python MPI sources, I gave the link here. You can take a look. There are quite a few the modules or the packages available for the sort of like cluster computing. We will just go through one, which is MPI for Pi. There are others as well. So depending on your interest, you can do other things as well. For the MPI for Pi, this is also there are like two pretty good slide the website which give a good introduction to them. So you're interested, I encourage you guys to check the website as well. Now MPI for Pi is just as the name stated, right? So you are implementing the MPI for Python. That is it almost okay. So it can support almost all the MPI cores, like all the MPI functionality. You can do it in the Open MPI. Then it can also be realized in the MPI for Pi package. So and it is pretty popular on the linear clusters and also in the SciPy community. So operations are primarily methods on the communicator, the objects, which I showed like a simple example in last class. But today we're going to go through like more details. Now, in order for realize the communication, right? So if you want to send a message, there are two things, right? You need to specify. One is who you want to send it to, right? So you need to so if you want to realize some communication between the objects, so you need to know who is your target, right? Who is going to receive your message, right? So that this is the first thing you need to specify. Then second is what you're gonna send, right? Object you want to send. And then there are other details about, like, say if you want to attach a tag to the message in case you want to send multiple the message to them to the same receiver, then they can distinguish the message, right? So and there are arrow check and other things. So but those are the things to make it more to make like communication more accurate. But basically, in your communication, if you want to send in the message from one node to another node, these are the two things you need to specify. And also there are different ways, okay, for the communication. You want to send in like a one-to-one from the process 1 to process 2, or you want to do a broadcast, right? Broadcast basically is if you have a message sending to every node, you can this is called broadcast. Broadcast basically you can sort of like send a message to everybody else. You don't need to do, of course, you can do like a one-to-one, just doing a for loop to send the same message, right? But if you that's gonna be less efficient. If you do the broadcast, we're gonna talk about just in just a second. In the broadcast, it can be faster. So there are different mechanism for you to send a message, right? So that's This is what we're going to discuss today. This is a communication optimized for NumPy arrays, because for the objects you want to send, because behind each object there will be some structures. It's all about like when you send the message, you want your message to be small, right? To be concise. So then you can pass information in the smallest amount of time. Now, NumPy array is this is kind of is optimized the communication can be realized in terms of MPI for pi. They kind of optimize for the NumPy array. So some preliminaries. This is sort of like the things you should know, like before we talk about more details. Now, a process is an instance of program, okay, can be created or destroyed. Basically, when you starting your program, right, and you're starting a different process, each process run one copy of your program, okay, each process run one copy of your program. That program can be created or destroyed, right? When it's when you start it, then the program is started run, and when it's ending, you can destroy it. Now, say you have the same program running on different processes, right, or the different computer node, then who is gonna do what is basically controlled inside your program, okay, inside the program. That you need to tell the program, because you don't want your say you're starting like 10 processes, right, run like a 10 copy of program. You don't want them to do the exactly same thing, right? So you want to distinguish them. So that part control is inside the program. Which we're gonna talk we briefly touch a little bit about using the multiprocessing, right? It's kind of same mechanism. Is when you say basically when you are process zero, right? The zero processor, what do you want to do? What the first processor, what are you gonna do? Second and third, and so on. So that part in when you write in the program, you need to define it. Okay, you need to define it. So typically you can, for example, you can basically say when you run the processor, if your processor, say you have 10 of them, right? The ID is 1 to 0 to 9. Now you can have in correspondingly, like say data 0.text, data 1.text. So you can based on what ID you get, what is rank of the processor, then you can go into say process the different data files, right? So that's how it's set up. Also it can be your rank has to be corresponding with like the key you want to process, right? So you have you have a mapping between your rank of the ID of the processor to the task you're gonna do. So this is also one part of the program, one part of your program to handle, right? So MPI uses a statically allocated group of processors. Their number is set at the beginning of the program execution. No additional process will be created. So this is different from threads. You created at the beginning of the program when you starting using like MPI run, and this is basically I'm going to show you in just a second. You guys show an example. Yeah. So if you using MPI run -mp, this is a number of processors 4. So at the beginning of your running it, okay, at the beginning of the execution, so you specify you're going to create 4 processors. So that 4 processor will stay alive for the whole thing, for the whole time, okay, until your program finish. So it's a static allocation. It's not dynamic allocation. So this is another thing. Each processor is assigned a unique number or rank, right? This is what I call the ID, right? If you have P processors, the ID by default is from 0 to P minus 1. So that means you have P processors. So then if you have the ID or the rank, then you somehow have to link your ID to the task it's going to do, right? Either to the file name or to the key or to whatever the other task you for the number of tasks you want them to do. So you need to do some mapping there. Number of processor is not necessarily number of processors. So a processor is basically, you can view it as computing node, right? On each computing node, you can start like several processes. You can run like multiple copy of the program. Like you run Python, you can start like several copy of Python on your computer, right? So that's so a processor is a process is basically is a copy of the program, and the processor is, you can view it as computing node. So a processor may execute more than one process. Okay, so that's ideally, you want like one processor run one process, because in that case your memory is like more efficient. This is so that's but in majority of the time you can run like a multi copy of the processors in there. So generally, to achieve a close to ideal parallel speed up, each process must have exclusive use of one process cores. This is when you are working in the HPC. Okay, now any machine out there, you are not the exclusive user. You have to bear that in mind. You are sharing that computing machine with somebody else. Within how what job is to assign to which machine, that is scaling. That's a scheduler's job, right? The scheduler how has like a Slurm. That's how they assign them. But once you assign it, there are somebody else maybe on the same machine as well. This is so they are ideally your process should be like occupy one core processor's core, right? One core in that machine. But in reality, sometimes you have to make sure share with other people. This is kind of out of control. Particularly for the CWOOF, you don't have any control of that. Running MPI program with one processor core is fine for testing and debugging, but of course, we are not giving parallel computing. So your MPI program should be able to run with just one core, okay, one core. But this is I encourage you guys to do that, because this is like for debugging purpose, for on a small data set. But of course, since on one core, right, there's no parallel speed up, but you should be able to run. Now, this is sort of like the things you should bear in mind when you run it. These are the sort of like the basics for you to run the parallel computing. Now, exchange data between processes. This is now you have to realize processes, they don't share memory. Okay, so each process has its own memory allocation. Of course, if on the different computing node, this is very easy to understand. They are physically, the memory are physically separated, right? But even in the same on the same computing node, two processes, they don't share memory as well. Each one has its own memory allocation, and then they don't share with anybody. So therefore, if you want to communicate data between processes, okay, explicit function calls must be made in the program. So if you want to say the process 0, they compute something, and then they want the process 1 to know, then that is called communication. That communication has to be done explicitly in your program, right? So so they can accept the computer, that they can accept the data from each other. Now, in the most basic exchange, the process which has the data needed by another process called the send function, and the process which has to receive data called the receive function. So both the send and receive function must be executed for the communication to be successful. So a basic communication is basically you have someone to send the data. Okay, that's called a send function. You also have someone to receive data. This send and receive has to pair each other. Okay, they have to pair each other. If you have a data, if you only send, no one is receiving it, you can cause error. Okay, if you have a function which only you try to receive data but nobody sending, that's also error. So when you try to communicating building the MPI, try to send in data, you have to pair the sender and receiver. This sometimes could be very confusing. Okay, could be very confusing because your send and receive, they are not in the same process. Okay, so you can see send, you may like a process 0, you have in a for loop, you send this to everybody else, right? To the every other processors. But then for every other process you may receive, if one of them you don't create this receive function. Say you skip, somehow you skip this the receive, then that's also gonna create the error in the communication, because that means somehow if your data is, think about it, right? If your data sending data, the data basically is passing to the to somewhere, right? So if you know nobody receive it, the data is gonna floating around, which is gonna also is creating problem for your network as well. Now so the send and the receive, these are the two most basic functions. Any other functions they are realized through this send and receive, right? So you can realize them. But these two as I said is actually pretty hard to use. Okay, pretty hard to use, because if you have like you only have two processes, one to one, that is easy. But if you have 100 or 1,000 processes running, then doing to end-to-end communication sometimes could be very tedious, right? Then you have to control everything. Also, this is less efficient, okay, as I'm going to explain in a second. It could be less efficient. In addition to this send and receive, we actually have people has developed, like in the MPI, the community, people has developed other communication method, like I said, is a broadcast, right? Like a scatter gather, and those type of the communication method, which is gonna making the communication much more efficient. Now, for the parallel program structure with Python, then basically these are the 4 steps. Okay, these are 4 steps. First, you need to import the MPI4Py module. Then the second step is you're going to initialize it, okay, making the MPI object. Then the next one is do computations, use MPI communication between the processors. Lastly, you're going to shut down the MPI. Okay, so that's the four steps you have to be including in all your program. Now, a minimum program, a minimum MPI program. This is sort of like the one of the this is sort of like this is like smallest program. Okay, you can have. So in here, we basically having the steps in here. So from MPI4Py import MPI. This is your importing MPI to the program. Now this is almost like if you have used MPI4Py, you need to load that every single time. Then next, you're going to create a communicator object, right? Using MPI.communicator word. So this is going to creating the communicator object. That's where you specify how many nodes you have, like what's the ID, and what are the physical, like the location of this. It's all inside here. Now, when you create this is the object, how many processes, right? How many processes you need to create? This create the processor is done using the in your Slurm file. Okay, this is specified your Slurm file. So your Python program do not specify how many processes you're going to run. That part is done in your Slurm file, and then in here you just get it, you just get this information. Okay, just getting the information to the program. Then using the get size function, so you com.get size, this is going to give you, see how many, the number of processes in the communicator, right? In this communicator word. So you start like 10 processors, then this size is going to give you 10. Yeah, you start 5, this is going to give you 5. Rank is basically get rank. This is your ID, right? This is ID for each processor. This is say your this is the each program you're gonna have an ID, know who they are, right? Who they are. This is how you how they distinguish or how they recognize each other. Now, lastly, you can print out. For example, this is a printout. The kind is hello. I'm a rank of the size, right? So it's coming from which one. Now, let's go to the demo. Settings. display color saturation the same. I still haven't figured out how to make it larger. I think there's default size paste using right click. Color default. There's did anybody see any there's a font somewhere? General. It used to be just okay. It used to be just using Control Plus. It's gonna it can show come on. Same. Okay, anyway, hopefully you guys can see it. Now, the program is in this over here. So this is where the program is doing now. I will go to my own directory. So in that case, you can see the so AMS example. So I'm going to run it from my home directory. Okay. Now, in here, I will show you the first thing is the hello world, the program. So let's say MPI hello world dot slurm. Okay, let's see. So in the MPI Pi the hello world the slurm file, in here you can see this is set up for the Slurm job, right? So this is if you have question about this, you should go back to the introduction to SIG. Okay, this is the Dave has introduced this. I will skip that, but the basic thing is now there's in this is aspect you specify how many node you request. Node this is the processors, right? So now you're basically saying I'm requesting 2 computing node. And on each computing node, I'm running 8 tasks. So that's a processor. So you requesting 2 computing node, each node you run like 6 tasks. So in total, you have 16. Okay, you can run 16 processors. So that's why in MPI for Pi or MPI run under here, dash MP, that means the number of processors. I'm running 16 processors. Okay, so these two you need to match them. This can be less, but it cannot be more than this node times task per node. Okay, so if you do that, then this actually I didn't try it, so you may not want. In here, you just load the MPI for Pi for the latest. This program only can run in the login when you do the login node. Okay, you log in if you're logging within the Milan node, then you need to change this a little bit because this is MPI. Also, the Slurm are different from in the Milan the login node. Now, there also you want to use in my queue is SHA-28 core, right? Again, as I explained last time, this is only available. This SHA-28 is only available in the login node. Okay, in the Milan node, you should use in 40 SHA-40 core. They are different. So to determine this is which queue you want to be in, you use sinfo, right? If you load it using sinfo to run it. So your module load this guy, and then you'll have MPI for Pi run. Then this is below here. This is the program you're gonna run. So I'm first use MPI run dash MP16. This is where I told the program I'm gonna run 16 processors. Then down here, this program they're gonna be running 16 times. Okay, so this will be specified the single program. This is called a single program multiple data mode, right? So at the first you specify how many processors have. Second, you specify your program and how you're going to execute it, right? Using the Python, you're using this Python code. So this is for the Slurm job. Create it. In the Python file essentially is the one I used in the these are the 4 lines in the slides, right? So you import MPI for Pi, you initialize you initialize the communicated object, right? So then the name you get in the process name. Well, the name this is just another so like this basically seems like ID. But this is get processor's name. Okay, this is getting processor name. This so remember we have two processors, right? We have two nodes, so they are process one and process two. This is not a size, so this is a when you print, you can just using the com.rank to get its ID, com.size, and from which node. So you can has all the information being you have all the information being done. Now let's do module load. I forgot the Slurm. Which Slurm is it? Okay. Slurm 17.11.12. Oh. Okay. Now, I need to go to the save instruction. Okay, so in the so this is what Dave has shown before. How do you the Slurm job. So if you guys have any like the question, you can refer to back. This is showing to this is the load. So in his example, he actually using the login load, right? So that's why you load in the Slurm. If you're in the Mila again, you can load a different thing. So this is the SBatch. This is submission of the Slurm file. So this is where you can do a submission. Now let's come back. So let's do S batch. Okay, MPI I for hello world dot I no Slurm. Okay, so if I submit it, then this is my job. Okay, this is my batch job. This is I can use in the I think SQ, right? SQU in UE dash U SOW. So I can see my job is running. This is a so this is my job. I don't know if it's finished. Okay, now it's finished. Now where did it go? It goes to the it should have okay. There you go. This goes to this is output is MPI for pi test.txt. Okay. PY for pi test.txt. Why it doesn't have anything? Oh, to the log. Okay, so you can see in the log file. Okay, in the log file, you can this is a printout. Say hello world from process 9 because this is a printout. You can see they are not in the order. Okay, because when you have in this 16 processes being out there, when they are printing out, they don't know which one is gonna finish first, right? So you can see you have a way to like to control it, but in here there's no need to control it. So you can see when you run the program, the order may be different as well. Okay, so this is how you each one of each line is actually printed out by one copy of the program. Okay, it's depending on. So you can see this is from process 9, and this is from the node is SN07. This is a physical name of the processors, the computing node, right? You're using this is a, so basically I'm using two node SN06 and SN07. It looks like 7 is faster, right? So you see everything is coming from 7 is finished first. 6 is a little bit slower. So you can see it's getting so so you can see the 6 has a drop from 0 to 7. This is from 8 to 15, and this is sort of like how you can see it can how the job is actually being executed. Okay. So this is a hello world example, very simple. This is in this example basically you what you do is just to get an idea. You didn't really do any computation, right? Computing you did is this guy print function is this print function is executed for every process. So you are not doing any computing or no communication between it. So this is hello world is just basically to tell you to identify them. Now, let's look at the one basic computing. This is using the send and receive data. Now, when you're sending and receive, you will need to fill in the details in the send function. When you send, say you have process 0, process 1, you send the data, you call the function process 0, you call send function, you wrap the data in there. So you're gonna send it to the process 1. Then in the process 1, you have to call receive function, okay, for the data as well to get in the data. Now, things need to be specified is how will data be described, okay? So the data is described. How will the processes be identified, and how will the receiver recognize or screening for the messages? What will it mean for these operations to complete? Okay, so these are the things you sort of have to specify in your program to tell them exactly what they need to do. Now, one thing is the send and receive, they are blocking operations. Okay, it can cause your program to hang. What does it mean? That means if you have a send, you have a receive. If the data, say this is called block operation. Basically, when your program run up here, okay, when you send in the data, if the data is not being received by another program, it will stop there. Okay, it will stop there. It won't go anywhere further. Then the same thing, if your program call the receive function, unless it receives the data from another processor, it will stop here. It will not go down further. So this is called blocking operation. Until when this is a send and receive, they pair together and the data has been transferred, then both processes can go down to their following lines. So this is called blocking. Sometimes blocking, there's another, I actually have an example for here. It's called barrier function. So barrier function is basically a function which block your program. Okay, you're saying the barrier function basically if you have barrier put in a program, then the program will not move on until every processor has to reach the same barrier. Okay, so this barrier function can basically try to synchronize your program. Sometimes your one process can run faster than another one. It may go, if you don't have barrier, you just keep going, right, to the executing the following code. But like in the MapReduce execution, you want to say for everybody, you want to have the mapper being done first and then do the reducer. So in this case, you want to put a barrier function in there. There's a barrier basically saying for every processor, for every program, it had to reach the same point before it going to the next, right? So the barrier function will be very useful for your second project. Okay, so this is one of the function. Of course, I'm going to show you barrier the demo in just a second, but I just want to tell you you will need to use the barrier function in your program. Now, so this is what a send is going to do. You have send methods of the MPI4Pi. It's an intro communicating instance. Then you send basically this is send function is written. You have a self, right? So this is just this is since Python, so they have a self object. Then you have object, which is this object contains the data to be sent. You have this is you have a destination. It's an integer because this destination basically is a rank, right? For each one of them, you need to specify where to go. Then you can also create a tag into there. Okay, you could tag is which can be used to distinguish among messages. The tag is if you send like a multiple message, you can basically use incremental it, right? Tag 0, 1, 2, 3, 4. Tell if you send into the to the different to the same destination, you can tag basically can distinguish your messages. Now this method may complete before data is actually being transferred if the object being sent is small enough to fit in the buffer used for MPI to communicate. So this is sometimes this could be the method could be like a send function could be finished very fast because as long as this function to send in the data to the buffer, then this send function is done. Okay, so you if you don't have a barrier, then it will keep going. But in reality, it can block it. It's basically receive has to receive before it going. Yeah.
This is more issue. C implementation. Yeah, we have to initialize the variable. Like, say we're sending something to another node. We have to initialize the variable that we're sending it to before we call the receive function to that variable, or no?
In here, you can see example. You need to initialize it. It's better. It's better to be initialized because if you don't initialize it, it can you may run some issues. You're gonna see in 1 second. Okay, you're gonna see the examples. You're gonna see how it can be handled. Now, in the receive function, for the Python, for the receive function, this may not be for if you want to do the scatter gather, you need to initialize it. Okay, if you do the receive, I don't think this can be you need to initialize. So because Python is a little bit. So the question was asking is should you initialize the object first or not to before you receiving data? It depends. Okay, it depends. It also depends on data you are receiving. So most of the time you can get away from, like if it's a simple like numpy array, you don't need to because that's the standard format. But if you want to send in specify like dictionary data frame, I think it's better to initialize it first. So the receive function is same thing. Gonna receive from the buffer. You want to have in the where the sources come from. And you also have a tag. Then the object, you don't have object in here, right? Object basically is object equal to receive, right? Then this is the object is going to contain the data to be received. Source will be the rank process from which to receive the message. Tag, you want to match with the tag with the send function. So this is to get in the data. And the status is information about data received. Now, this method will not complete until the corresponding send function has been executed on the source process and data has been successfully transferred. So this is where the blocking is coming to play. Now, this will be example. Then the first thing you want to load MPI, create a communicator object, right? You get your rank, then you get your size. P is a size. Now in the program, the program is going to be distinguished between the process. What you're going to do, right? So if my rank is not here 0, that means suppose let's say 0 is the root rank, right? Is a root processor process. Then if my rank is not 0, I'm going to say print the message. It create a message, right? It's hello from my rank. Hello from the rank 1, 2, 3, right? Is if it's not 0, I'm gonna send a message to the root process. So you can see the send. You have a message which is this string, and the destination is 0. Destination equal to 0. That means you're sending to the 0 process, the root process. Else means if I am the root process, right? If my rank is equal to 0, what I'm gonna do is I'm gonna run a for loop. I'm gonna proc ID in the range from 1 to P. This is basically a loop through all the rest of the processes. And the message, okay, message will be equal to receive source equal to proc ID. So in here, that means I'm receive a message, okay, I'm receive a message. And then this message is coming from the proc ID. Proc ID is 1 to up to p minus 1, right? So that means I'm from other things. So now this message will be sending from the process 1 or process 2. So then next thing I'm gonna process, then the printout say I received the message from this is the proc ID. So in here you can see what are we doing here? Now we are kind of separating the program a little bit, right? Now because based on you are the root processor, basically 0 or not, you're gonna run different thing. Okay, now you different. But this is you can see. But the one thing is the send function and the receive function they match. Okay, they match because you're gonna have p minus 1 send function because each process 1 to p minus 1 they're gonna execute the send function. Now in the root process, you have a for loop. You also have in p receive function, where you receive p message from the different one. So you sometimes this is very important when you debug your sometimes when you have in the this is the program writing, you have to think about go through your logic. When you are process 0, what program you're gonna execute? When you process 1, what program you execute, right? So you need to have this logic to be very clear because now you have remember your program is not running on the one copy in the local machine anymore. You are running multiple copy in the multiple sites. Okay, so you need to go through this is a logic in your mind to figure out which one gonna execute which part and who is gonna do what. This is particularly important. You gonna feel if you haven't I think there's some a few students have experience with MPI before, which is good. I think majority of the class did not have any experience with MPI. So I would envision some of you are gonna struggle, okay, because the programming is pretty different from you run on the single on a local machine because now the mindset has to be different. Okay, now let's see an example. So the example what I'm having here is send and receive, right? So I have this send and receive, VI. So the copy okay, MPI I send. Let's look at the Python code first. This send and receive function is a little bit more complicated than the one we had it in the in the slides. So let me explain what this does. So basically what I'm doing here is I import the MPI, so that's a regular, right? I create a com object. Now I get my rank and get a size of the program. So these 4 lines, pretty much you need to have you have it in like every MPI program, okay? Now then I create in here. What I do is I create in here. I have like 2 process. So first I initialize my NumPy array is A. I have this is a 1 0 to 6. I mean this is a you can do using a range or the have better way to create it, right? So this is anyway. So this is just create a NumPy array. I want to just show you exactly what's in there. Now you have a my A. This is your own copy, right? Right now it's empty. Okay. So if my rank equal to 0, so if I'm the first, I'm the 0 ID, then I'm gonna send this is a 0 1 2 this copy, okay, to the destination 1 with tag 1. So that's I'm sending this array here. It actually doesn't. I didn't use it. It's just I'm sending this is the list, okay, to the destination 1 with tag 1. And then the A1, I'm going to receive, okay? I'm also going to receive, I'm going to receive something, okay? I don't know, yeah. It's hard to see, right? That's what I try to do. I want to zoom in. I don't know how can I get it a little bit larger. Do anybody know how to zoom in into a mobile Xterm? Like, okay. View. Oh, problem view. I can show manual button. Tools layers. Okay. All right. Let me just do how. Okay. How to increase font size in mobile Xterm. Okay, see if it is good. To increase size, hold the control key and scroll down your mouse wheel to zoom in. Okay, control key. Control, what is control key? Scroll down your mouse. Oh, actually, it actually worked. Okay, good. All right. Is it better? Okay. Okay, so what it does here, if you're rank 0, you're gonna send this is to the Destiny 1, and also you're gonna receive something from source 1, right? Then this is the first one. You're gonna also, after that you're gonna send another message is 10, 11, 12 to Destiny 1 with tag 2, and also you want to receive something. Now basically now you having, after you do that, then my A was empty, it's empty list, right? Now you can do A1 plus A2. I'm assuming here is A1, A2 are also the list I received from the source number 1. So in here is printout is I'm a 0 processor. I can use in my rank here as well, but I'm just list, well, just hard coded as 0, right? So my A is, this is my list is going to be equal to the whatever I receive. So if you are rank number 1, what you're going to see, you're going to receive, okay? You're going to receive from the source 0, and you're going to send in 4, 5, 6. Then you're going to receive and send again. Now you're creating the new in the rank 1. What you're going to receive is B1 plus B2, right? This is what you receive from there, and you print it out. You can see when you have this program, if you are rank 0, okay, you're gonna receive data from A1 and A2. Basically, that's from the what the rank 1 is gonna send. Basically, is 4, 5, 6, and 14, 15, 16. Okay, so if you are then finally print out, if you're 0, then the my A is gonna be 4, 5, 6, 15, 16, 14, 15, 16. If you are in the rank 1, your printout is the data you receive from the rank 0. So in the printout, it's gonna be 0, 1, 2, and 10, 11, 12, right? So this is from the program. This is what we're gonna so like expecting to see. Now if we can see the Slurm file, in the Slurm file, I'm only running starting 2 processes, right? So which is actually requested like 4, right? Requested like 4 tasks, but I only use 2, so which is fine. Then I'm gonna do that. Now actually I think I already have my log being printed out. Okay, so this is I already run this beforehand, so guys, we don't need to go through this. I already showed you how to run the submit job once, right? So you know how to do it. So you can see here in the process 0, my object is, my list is 4, 5, 6, 14, 16, 14, 15, 16, right? My A in the phase 1 is getting the 0, 1, 2, 10, 11, 12. Okay, so which is exactly the what we expected. Okay, so this is just to show you using the send and the receive function to send the data. So to write the simple MPI parallel program, you only need these things, right? The MPI for pi, this is imported and create the com object. You get rank, get size, you send, receive, and finally when you program design, MPI is automatically killed. So you don't need to stop it explicitly. But this is how you done. So these are the basics, okay? But beyond the basics, MPI provide many methods which can make your program more efficient or more convenient to write. Then probably the most useful are this is sort of collective communications. Collective communications involving all the processes in the communicator. So the one which you're gonna probably use most commonly is a broadcast. Okay, and gather, scatter and gather. So let's just look at the what it does. Broadcast is basically this is a bcast function. This is bcast called is basically broadcast, right? So broadcast, when you broadcast, you need to specify the object. Okay, so you need to specify the object, and also you need to specify what is the root for the broadcast. Broadcast basically what it does is you're gonna send this object from the root processors to everybody else. Okay, so if you have 10 processors, you send the object from root 0, then 1 to up to 9, they all gonna receive it. Then the rank broadcast this is the basic root specify where your broadcast come from. Okay, so you can come from root if you 0 processor from 1 to, so you can come from any processors. So it's just this root just to define where they can come from, and the destination will be everybody else. Okay, you don't need to specify destination. So basically, you can skip the for loop, right? Remember in the this is send function. We basically this is a broadcast. Okay, this is a broadcast. But what I'm doing here is I'm using the for loop to do it. Okay, but this whole thing here can be realized just using one broadcast function. Okay, it can be done. So a lot of this is your communication actually can be done in the broadcast. Now the broadcast. First of all, the broadcast is going to be make your code is much more simple, right? Concise. Secondly, it actually can make your program more efficient. Okay, more efficient. What does it mean? That means if you are, let me write down to the whiteboard so you can, because now I write on the whiteboard. You guys cannot see. I have to. Where is the whiteboard? This one? No. Turn off. Okay, share. Okay, here's the whiteboard. New. Don't show again. Now, see, suppose you have like a 0, 1, 2, 3. Okay, let's just say I'm just using very naive methods. Okay, so suppose because we talk about the HPC structures, right? Your computer are connected, not connecting through like every computer is not connected to every other computer. This is your node is not doing by like that. Your node is connected through some mechanism, right? Through the mesh structure, through a tree structure, through some structure. Okay. Say suppose you have 4 processors. They are running on this is the 4 computing node. They are connecting using this is a linear way. So if you want to do this is actually I don't think this is gonna actually making it efficient, like still the 4. Okay, 5. Now, when you try to do the communication using the for loop, okay, using the for loop, that means, say you want to send in some message from 0 to everybody else. Now, from 0 to 1, this is one communication. You're gonna pass in like 2. You have to pass 0 to 1, right? When you do the send to the 0 to 4, then you have to go through 1, then to the 4, right? You have two, so like 2 hops, right? To 5, you're going to do 0, 1, 4, 5, because there's no direct connection from 0 to 5. If your message is going to get in from 0 to 5, you have to go through 1 and 4 first, right? So same thing from 0 to 3. This is how you're going to do. So you're gonna need this is the communication. Actually, the message passing is the length of the message passing actually can be long. But if you're doing broadcast, okay, broadcast knows you will go into message from everybody else. So once the message is sent to 1, okay, then the program knows, then the next, most efficient way is not directly send the data from 0 to 4 or 0 to 5. Rather, it's going to directly just going from 1 to 4. Okay, so that's when you're doing the broadcast actually can handle that. So in that case, you can once the node 1 has received data, then it can go to 4 and 2 directly. Once the 4 and 2 have data, then go to 5 and 3 directly. Okay, so therefore you don't need to, like, every single time you have to using the from like end to end. But if you're using broadcast, you can actually using the intermediate the node for the communication. Okay, so broadcast is not just simply your program is, of course, it will be more complex, but it's in terms of communication, it actually make it faster as well, more efficient. All right, so that's now the broadcast is actually I have the slide. So this is a full implementation for the broadcast, right? You're using a loop, you 0 to everybody else, but then if you only in that case you need 8 steps for the if you're using a loop to the broadcast, right? You need 8 steps. But if you're using the topology, right? The how it connected, you only need like 3 steps, right? For it to be complete. That's where they're using the broadcast is using parallel. You not only you can use sort of like parallel the communication, right? Making it much faster. Now, in here, this is the example for the broadcast. You're getting the data from myRank, right? So you have in ABH, you have in this is so like you should like initialize this as 3 variables. If myRank equal to 0, what I'm gonna do is, if myRank is equal to 0, I'm gonna print out this is myRank. I'm gonna input this is getting an input for the A, B, and N. Then you print out ready to broadcast. Now for the this is in the rank A. Okay, this is in the rank A. If myRank is equal to 0, I'm gonna initialize ABH. I'm initialize these 3 values. If I'm not in the root process, I don't need to initialize. I'm gonna have none at the beginning, right? Now, A equal to broadcast A. Here, if you don't specify the root, by default, the root is 0. Okay, so that means when you're doing this, what you're gonna do is, if your rank is if the rank 0, then you're gonna making the broadcast A to everybody else. Okay, so if you having this is a B, you're gonna broadcast to everybody else, and then the N is the same thing. Now, of course, if you are not, remember, if my rank is 0, you're gonna broadcast. If your rank is not 0, in this case you are not gonna broadcast, because the broadcast is from rank 0, right? So if your rank is not 0, you are not gonna broadcast. What you're gonna do is you're gonna receive it. Okay, what you're gonna do, you're gonna receive it. So therefore, then you return this ABN. What you're gonna have is getting from the other, from the rank 0. Now, let's see a program for the broadcast. In here, the broadcast is why is this okay? So in here, I also getting a barrier function here. Okay, this is a now for this broadcast is the same thing. You want to import your MPI, you get a communicate the object. Now in here I do some printout. I'm print hello I'm a rank from the which one. That's basically is a print ID. Now I also have this is called a com.barrier. This is a barrier function I talked before. The barrier function, what it does is it's gonna block everybody until block everybody every program until all the process has been reached the same point. Okay, so in this case, if you only when all the point has reached to here, then you can execute the following the following program. So basically, what I'm seeing here is in my output, I want everybody to upload this hello message first. Yes. Block basically means your program is gonna hang. You're gonna stop at this point until every other, say you run like 10 processes, right? So then the process 0 may have is faster. You're gonna print out this execute print function very fast. Then you're gonna reach to this point. Okay. When it get into this point, it's not gonna go executing the script after this line. It just stop here. Okay, then the process 0 gonna stop here. Then see you have process 1. It took 1 second to get into to this line. Then then you got when it's done, it also stop here. Then you have 10 processes. It basically has to have all the 10 processes has all been finished to the script before this is a barrier. When everybody reach to this barrier to this point, then they can go at the same time. So you kind of like you kind of restarting the starting point for every processes, okay, to synchronize them to the same starting line. If you don't have this, okay, if you don't have this, say the process 0 is very fast, then you're gonna have him print out this message. Then you're gonna keep going to the down before to the script down below. So you have another print function. Then this is a print function for the first process may having this print function been done before the process 1 even going to print out this first message, right? So in that case, you can see your can making your program, like in this case output be pretty messy, but in more important, like in the MapReduce, this is could be your mapper function for the process. Mapper function is already been done. It already jumped to the reduce function, but then the input hasn't been ready yet. So that's going to create the bigger problem. Okay, so the barrier, what it does is basically you synchronize everybody to the same point. Okay, so that's this is what it means. So when you think about this barrier, you have to think about now you not just have one program running. You have 10 programs running, right? So they have to reach the same point before they can go again. Now in here I'm having n equal to 5. So if my rank equal to 0, I'm going to initialize this is a numpy array, which is 0, 1, 2, 3, 4, right? So else I'm going to create an empty. So in this case, I do initialize my the receive object. Now when you do the broadcast, okay. So when you do the broadcast, then this is basically I'm going to broadcast. This is a. Now in here this is another trick is to be specified. Now when you want to broadcast, sometimes you want to if you want you can specify the type of the object. Say MPI.double. This is basically specifying my the object A is my object A is double in the precision. So in this case, it can give you like the more control. If you want to have a more control of the program, this is what it does. So in this case is you can if the broadcast again, I don't have this is the root here. That means the by default is from root 0. So if it's a 0 processor, you're gonna initialize this is a object, and if it's not, you're gonna initialize make it to be empty, right? Initializing is empty. Now this is broadcast. Basically, you're gonna broadcast this is a from rank 0 to everybody else. So then everybody else should have the same, right? So you're gonna print out the rank and also to the object. So this is how it's done. Yeah.
So do we not need a receive function for the other processor?
No, broadcast, that means when you call the broadcast, that means you already has the if you are not the root processor, you are receiving it. Yeah.
That's why doing slices.
Yeah, you can want to do you can do the initialization if you have an array or it's a more than one object. But if you're just scalar, you don't need to initialize it. Like in here, like in the example here, this is I also initialize it. Broadcast, yeah, it's better to initialize it. So in that case, you can have the you can receive the correct the message. Okay. So I think yeah. So this is what this is wrong before. So you remember I have a hello message, right? So if I don't have this hello have barrier function, it could be okay. It could be this later print out can be jumping up forward. Okay. So what I'm doing here is basically saying first is I'm get a print hello message from everybody. Then the second one, this is just showing you before initializing, before the broadcast, all 0, and after broadcast, I'm receiving from the everybody else. So this is basically this is how the broadcast is done. I think is okay. So let me just I think I probably need another. I want to get in another operation is reduce. The reduce function is also this is where you can okay, for your project number 2, you will need to using I think you once you know the barrier function, you have the broadcast, you should be able to do in the project number 2. Okay, so if you are a little bit more advanced, you can try to using the reduce function as well. Reduce function can also help you with basically this can correspond to the reducers in the reduce map reduce, but I only have like a 1 minute. What it does is basically is what it reduces does is you having operators being you have an operator being coming from the reducer. That means when you having this is you have the if the data from all the process are combined, use a binary operations. In this could be some like a minimum to sort of like reduce the object you kind of received from everybody else. So this is a better. This can be seen from the anyway. So this is I don't think I have enough time to go through it. So if you are you can sort of like explore this a little bit. Okay, reduce function. You can try it out. This is another function is a scatter and gather. Scatter and gather could be also could be helpful to the project too if you know how to use it. Okay, but if you don't know how to use it, that's fine. For the project number 2, I think the thing you just need is if you know how to use in the barrier, if you know how to use in the send and receive, and if you know how to use the broadcast, okay, that should be enough for the project number 2. They are more like the advanced, like this is a more efficient communication methods. This is get and gather. This is pretty useful as well. This can be if you know how to use it, feel free to use it. But if you don't know how to use it, just stick to the burial, broadcast, and send and receive. That should be enough. Okay. Okay, so that's all for today. I mean, hopefully you guys can work out the project until without any problem. But if you have any issue, let me know. So next Monday there's no class, right? So I gotta see you guys on next Wednesday. All right, have a good break. 1 second.